This movie covers subtopic 8.3, Solid Domestic Waste, under the main topic of IB ESS Topic 8, Human Systems and Resource Use. The significant idea number 1 for this subtopic is that solid domestic waste is increasing as a result of human population and consumption. Take a look at this graph showing the growth of solid domestic waste in millions of tons per year by different regions of Earth over time. This also includes predicted growth. Solid domestic waste, or municipal solid waste, is our trash, garbage, rubbish from residential and urban areas. It is a mixture of paper, packaging, organic materials such as food waste, glass, dust, metals, plastics, textiles, paint, old batteries, electronic waste or e-waste, and more. As a nation, Americans generate more waste than any other nation in the world, officially between 2 and 3.2 kilograms per capita per day. Here is an image of the categories of solid waste disposal in the USA between 1960 through 2014. This graph also illustrates that there are different types of solid domestic waste of which the volume and consumption changes over time. You can see that in the 1960s, the proportion of food waste and durable goods was different as compared to the proportions in 2014. You also see an increase in volume of all categories of solid domestic waste over time. The abundance and prevalence of non-biodegradable waste, such as plastics, batteries, and e-waste, in particular has become a major environmental issue. What is the problem with non-biodegradable waste? It can last for centuries and cause environmental problems that affect more than just the land. It also washes into seas and oceans, where it has devastating effects on marine wildlife. Non-biodegradable plastic containers in oceans and estuaries can harm fish, seabirds, and other marine life. Animals that eat plastic can strangle or experience digestion problems. Also, microplastics, tiny bits of polypropylene or polyethylene, hide beneath the water and pose a risk as well. Plastic debris undergoes weathering and is broken down into smaller particles, which may be ingested by invertebrates and fish. Predation of these organisms can result in microplastics infiltrating the entire food web, potentially affecting birds, marine animals, and also humans. Microplastics measure less than 5 millimeters, and one simple reason that fish eat them is that they can look a lot like the food that fish naturally hunt. And this might not be the whole story. A recent study involving anchovies, one of the fish species found to be eating microplastics, shows that smell may also play a part in this occurrence. You can see the fish's logic. If it smells like food and looks like food, chances are it's food. While it's worrying that fish are eating plastic, anchovies were chosen partly because of their position in the marine food chains. Anchovies eat krill, but in turn are eaten by creatures ranging from other fish to whales, birds, and even humans. It's already been shown that plastics will pass up the food chain from prey to predator. The presence of plastics in southern bluefin tuna, captured near Tasmania, has attributed to their predation on smaller fish species. And so yes, that means we are eating plastics too. In fact, 55% of fish species we eat have been found with microplastics in their gastrointestinal tract. Additional studies show that microplastics also accumulate in the flesh of fish. 70% of deep sea fish have eaten plastic, and 100 different anchovy species, those low on the food chain, have been found to consume microplastics. Non-biodegradable waste also includes e-waste and battery waste. Electronic waste is the fastest growing waste stream in the world, and batteries form a huge part of that waste stream. As batteries are made up of heavy metals and other toxic elements, these leak into the environment and harm humans and animals when not properly discarded. The numbers are astounding. Upwards of 50 million tons of e-waste are produced each year, and left unchecked, this could more than double to 120 million tons by 2050. It is difficult to imagine even 50 million tons. Yet this is the equivalent in weight to all the commercial aircraft we have ever built throughout history, or 4,500 Eiffel Towers, enough to cover an area the size of Manhattan. And that's just 1 year's worth of the e-waste that we as humans create. To deal with our solid domestic waste problem, we are going to need a paradigm shift in how we think about economy. The linear economy, the foundation of our current global economy, is a take, make, and dump model that until recently has always been used in product design and business models across the globe. A circular economy is more than just recycling. It's about keeping products and materials in their highest utility and value throughout their life cycle and recirculating them at the end of their life. The circular economy has the potential to generate innovations and new employment opportunities in the so-called eco-industry based on the development and application of eco-technology, as well as the potential to geographically shift back outsourced activities to national economies in processes labeled as local mining, near sourcing, or reshoring. In the past decade, the eco-industry has more than doubled in size in Europe. This third advantage concerns the reduction of environmental damage due to less extraction of raw materials, less fossil energy use, and significantly smaller waste disposal problems. A circular economy is sustainable because it aims to be restorative to the environment. It uses renewable energy sources it seeks to eliminate or reduce toxic wastes, and it aims to eradicate waste through careful design. To fully adopt a circular economy, a paradigm shift must occur. The circular economy idea must be designed into new products and business models from here on forward. Significant idea number 2. Both production and management of solid domestic waste can have significant influence on sustainability. Can you think of a connection between per capita solid domestic waste and a country's sustainability? High production of solid domestic waste leads to unsustainability, and the inability to manage solid domestic waste also leads to unsustainability. Sustainability will be achieved through low solid domestic waste production and well-managed disposal of the waste. You need to be able to evaluate solid domestic waste disposal options, and you need to be able to compare and contrast pollution management strategies for solid domestic waste. Waste disposal options include landfill, incineration, recycling, and composting. These strategies can be divided into those that minimize waste and those that dispose of the waste. Strategies that minimize waste include practices you've learned about since you were in elementary school: reduce, reuse, and recycle. How can we personally reduce waste? Buy things that will last. Buy only food you will eat and use reusable containers for food storage. Repair rather than discard. Buy items with less packaging. Buy products that are made from recycled materials. Choose energy-efficient products. Avoid imported items. Print double-sided and use electronic documents. Do not buy plastic. And be aware of how many resources you are using in the home with regard to water and electricity. We can minimize waste by reusing or donating clothes, books, electronics, and rechargeable batteries, by composting food waste, by renting instead of buying, like using ebooks, and using returnable bottles. Recycling involves sorting waste into separate containers for recycling before it leaves your home. Germany has the best recycling rate in the world. Austria comes in second, followed by South Korea and Wales. All 4 countries manage to recycle between 52 and 56% of their municipal waste. Switzerland, 5th in place, recycles almost half of its municipal waste. Recycling plays a part in the green energy debate by reducing the amount of energy required to manufacture certain products. This reduces greenhouse gas emissions generated by manufacturing processes, and lowers global energy consumption. Consumers see the impact through lower prices. When you recycle, you also eliminate the need for manufacturers to acquire raw materials through processes such as mining and refining. They've already got the material they need from you, so it's just a matter of repurposing it. Recycling also decreases pollution by drastically reducing the amount of industrial waste. Instead of those soda cans going into a landfill to clutter the earth, they're taken back to the manufacturer to be broken down and reused. The less waste we throw onto the planet, the cleaner and safer it will be for future generations to come. By recycling, you limit the need to mine and use raw materials to make new products. Instead, your recycled materials are used. Disadvantages. Establishing new recycling protocols often involves high initial cost. Recycling isn't a process that just happens. There are units that need to be set up, factory upgrades that need to be made, and attaining trucks to haul the recycled material. You also need global buy-in. It is certainly a critical step that the global population has to make to reduce pollution, but there's a catch. A lot more people need to start participating. Recycling is most often prevalent in homes, schools, and some office parks. The kind of recycling that occurs is putting used paper products into blue bins and hauling them away for reuse. The impact is rather small compared to the massive amounts of waste and deforestation taking place on an industrial type level. Quality. Products made from repurposed materials simply don't stand up quality-wise to new material. They're often fragile and overused. The more a piece of material gets recycled, the worse it gets. I highly recommend that you watch the Jeremy Irons movie titled Trashed to get a good perspective on solid domestic waste management strategies. I'll briefly discuss landfills, incinerators, the generation of fuels and fertilizers from digestion of biodegradable matter, and composting. A landfill site is also known as a dump, a rubbish dump, a garbage dump, or a dumping ground, and it's a site for the disposal of waste materials by burial. Landfill is the oldest form of waste treatment, although the burial of waste is modern. Historically, waste was simply left in piles or thrown into pits. Landfills have been the most common method of organized waste disposal and remain so in many places around the world. The advantages. Landfills are convenient. They keep a city clean, and they can be used to generate energy from the waste, and they are safer than incinerators. The disadvantages. It does result in a pileup of toxic waste. They release methane. They also release dust, pollution, and particulate matter. There is the issue of leachate. When precipitation falls on open landfills, water percolates through the garbage and becomes contaminated with suspended and dissolved material, forming leachate. If this is not contained, it can contaminate the groundwater. And of course, the decomposition gases of carbon dioxide and methane come from rotting food and other decaying organic waste. And of course, as you know, they contribute to greenhouse gases. And this can happen in different parts of the landfill. Incinerators involve the combustion of organic substances contained in waste materials. Advantages. They eliminate germs and chemicals. Incinerators involve the combustion of organic substances contained in waste materials. There are many advantages. It decreases the quantity of waste. It can be used to produce heat and power. It prevents the production of methane gas, and it eliminates chemicals and germs. The disadvantages. It can be expensive. It pollutes the environment. It does not encourage recycling and waste reduction. And the ash waste itself can harm the environment and people. An anaerobic digester involves the process of treating biodegradable waste and sewage sludge using anaerobic digestion. It produces energy and fertilizer. It can sanitize waste, and it reduces the spread of waste. Advantages. The disadvantages, as you can imagine, it requires a high level of investment, and if it's run inefficiently, it can cause an odor problem. Composting is a natural process of recycling organic material, such as leaves and vegetables, into a rich soil supplement. Compost has an abundance of nutrients and is suitable for a wide variety of end uses, such as landscaping, topsoil blending, and growth media. Nitrogen in compost is released more slowly and is available to plants over long periods of time, which is more consistent with plant uptake needs. The main disadvantages of compost are the following. It does require a large amount of space, right? If you have to aerate these piles and turn them over, you need space. Odor can be a problem. And ambient temperature and weather can have an influence on the composting. In-vessel containers are expensive and have limited flexibility to handle large quantities. You need to be able to evaluate, with reference to this figure, pollution management strategies for solid domestic waste by considering recycling, incineration, composting, and landfill. There are a variety of strategies that can be used to manage some solid domestic waste, and these are influenced by cultural, economic, technological, and political barriers. These strategies include altering human activity. This includes reduction of consumption and composting of food waste. Stop the movie and study the slide to look at different aspects of human activity that can be altered. These strategies include controlling release of the pollutant. Governments create legislation to encourage recycling and reuse initiatives, and impose tax for solid domestic waste collection. Impose taxes on disposable items. Again, stop the movie and study the slide for this level of strategic management. These strategies include controlling cleanup and restoration, reclaiming landfills, use of solid domestic waste for trash-to-energy programs, implementing initiatives to remove plastics from the Great Pacific Garbage Patch. Again, stop the slide and study this level of pollutant management. Here is a general summary of topic 8.3, solid waste management. This ends the movie for IBESS topic 8.3, solid domestic waste, under the main topic of IBESS topic 8, human systems and resource use. The slides are created by me, Dr. Nina Markham. Images are courtesy of Creative Commons unless otherwise indicated, with a citation under the image. If all images on a slide are from the same resource, the source is simply cited at the bottom of the slide. Other resources for you are your IBESS textbook, whether in hardback form or online, such as Cognity. Thank you for listening.